Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you.
Okay, so in the previous video tutorial, we contrasted or compared the two Sentinel images with one another. So remember, we in video tutorial 81, we generated a Sentinel image using this Sentinel Hub website, their browser, and then in video tutorial 82, we generated a Sentinel image using our trusted Google Earth engine. And so in both cases, we downloaded these images, or the image that we've created in each one of them, and we moved it into QGIS. And in QGIS, we sort of compared the two with one another to see whether these images are they very different, are they very similar? If there's one that's better than the other, how do they compare, and all sorts of things. So that's what we did in tutorial 83. And we basically came to the realization that in the main, they are exactly the same. So the features that they present are the same. If we have the same value, minimum and maximum numbers per band, and we combine them, we stack them, and we compare them, in the main, they're basically the same. But importantly, or interestingly, the Google Earth image seemed to be the better image, specifically because of its higher resolution, i.e. its pixel sizes are smaller than the pixel sizes of the Sentinel images from the Sentinel Hub. So it gives some confidence that Google Earth Engine is a better platform to generate these images than the other platforms. So that's at least a plus. But I also need to caution that in some instances, you actually cannot use the Earth Engine images because they are stacked automatically. You actually need the individual images, or the individual bands, excuse me, and then you stack them within the specific program, and then it works. So just bear in mind sometimes that the Google Earth Engine image, which is already stacked, etc., doesn't work. And then you have to go back to the original images or the images from a different source. And that's why I demonstrated both images. Okay, so let's play around with the image in Earth Engine. Remember, the first thing that we had to do when we generated the image in Earth Engine is to include a scaling factor. Now, you don't have to do it. That's just to take note that if you get a value of 0.002, that's not actually the reflectance value. The reflectance value is actually 2000 because of the scaling factor. And the Sentinel-2 image has 12 bands. It has more bands, but for practical use, we only use 12 bands. Remember, there's no band 10, there's a band 8A. 8A, yeah. Okay, so those are the bands. And remember, the bands measures the reflectance value, meaning the difference between what is absorbed, remember, an object receives that incoming light. And some of that light, it absorbs, and some of the light, it reflects. Now, these bands measure, or the satellites measure the reflectance. So the higher the reflectance value, the less the absorption value. Remember, we see what is reflected. Okay. So that's basically how it works. So if you know the spectral signature, meaning the reflectance values of these objects, and then you know the reflectance values per se, you can identify the object. Well, that's how we can identify objects on Earth using its reflectance value. And objects have different reflectance values because not all objects are exactly the same. So they absorb and reflect different values of different degrees of light. Okay, so the reflectance values are very important. So this whole image here that we present here is based on the reflectance values within the true colors, meaning blue, green, and red. Okay, so how do we generate it? Using our trusted script. Remember, daytime images, whether it is Sentinel or whether it is Landsat. You have clouds, because most time of the day there's clouds in the air, so we need to remove those clouds. And that's the script to remove the clouds. Okay, that's that specific script. To remove the clouds. Okay. Then basically we generate our image from our image collection. Remember still what's the image collection? Image collection is multiple images. Now we have a month period here that we have specified. Whether there's multiple images or not, I don't know. Most probably there is multiple images, most probably maximum 2, because I think it's a 16-day cycle. We can go and find out. If we go into the details, I think almost it's a 16-day cycle to generate the whole map of the Earth, I think every 16 days. So therefore, there's likely that there can be 2 images, but I don't think it's more than 2 images. Then we filter it for the clouds, and we clip it for our region of interest. Then we apply our scaling factor. Okay, our scaling factor, in this case 1000. There it is. If you go to bands, there it is. And then obviously, because there's multiple images within that image collection, we have to reduce it. And we reduce it by using a median. And many of our previous video tutorials, we indicated, or we clearly showed that using the median is much more beneficial, much better than using the mean or sum or minimum or whatever it is. Then we have our visualization parameters. Remember, these are now scaled. Okay, so they are multiplied by 1000. So minimum is 1000, maximum is 10,000. Our bands, these are 2 color bands, red, green, and blue. And then we basically display it and we basically export it. Okay, there's others we're going to continue on the other day. So that's our basic script to get going with Sentinel. Okay, and again, we can change the dates. That's up to you. You can make it longer, you can make it smaller. Well, you can't really make it smaller because then you're not going to have any images. So you can make it longer. That is totally up to you. Remember, in one of the previous videos, I spoke about generating this image in different seasons. Because obviously, in this case, what we've presented here is a very, very dry period in the West Coast. So the region of interest is basically very dry. It hasn't received a lot of rain, so vegetation is sparse, it's very brown, there's lots of sand. And that's a big problem because to differentiate between sand and urban areas are very, very difficult. The spectral signatures are very similar. So then in one of the videos we also looked at winter, because winter is obviously much more green, so therefore it cancels to some degree the sand stuff. Yeah, that's something that we're going to do again. So just as a matter of recapture or going back into time, so to speak, that's now we've created an image. Okay. Now, we can basically generate, if we go to inspector, the spectral signature of any of these objects. Okay, so let's say we zoom in. I'm just going to go back so that I can move it a little bit, and let's just zoom in a little bit. So that we have an urban area, some sand, some water, some natural vegetation. So all of those are included here. So I've just zoomed in so that we can choose our feature much more carefully. Otherwise, it's a bit of a hit and run if we zoomed out quite far. So there we can see a couple of features. Okay, let's zoom a little bit more in. Not much, just a little bit more in. I want to zoom in. Okay, so I go back to my inspector. There's an open field. There, let's have a look what each spectral signature is. So you just, as I said, in the inspector, you just left click that, left click, and then in here the spectral signature. There's its spectral signature. So it's a reflectance value in band 1, which is aerosol of 1 to 1. It has a reflectance of B2, which is, remember, B2 is blue. Just confirm. B2, band 2 is blue. Right? So B2 is 184, B3, B4. So it is reflecting much more red than green, which is reflected more than blue. So it absorbs more blue and less green and red. Okay? And vice versa. It absorbs very little red, it projects a lot of red. And therefore the sandy is a more reddish color. So let's have a look at something more, okay, green. There is something more green. Let's have a look at the green. That is sports fields. That's a sports field there. Soccer field, rugby field, there it goes. Have a look there. Soccer field, where's green? You see there's the band 3 is green. So it reflects a lot of green, not a lot of blue, and not a lot of red. So that's why it looks green, because it reflects a lot of green. But you can see this differences in the spectral. Okay, so let's quickly yeah, you can see the difference in the spectral signatures between these objects. Okay, so let's have a look there. That's band 3 is green, confirm. Band 3 is green. That's why it looks green, because it reflects a lot of green. Let's have a look again. It's 126. Okay, DN value of 126. Let's look at the sand. Let's look its green reflectance. Its green reflectance is 248. So that's quite a lot. Quite a big difference. Let's have a look at we don't know if something blue. Water is supposed to be blue, but this is winter, so it actually doesn't present a lot of blue. It actually presents, why is this now? Let's have a look and see. There's some water there, but I doubt it will be. All the water pools are basically dried up. So let's have a look and see. Okay, let's go to the middle of the river there and see what that looks like. That's in the middle of the river, and you can see its reflectance of green again is much higher, but you can see the spectral signature of the water. It's very, very different than anything else. Let's click on a urban. Let's click on a building. You see, this is why we have to zoom in. There's a building there. Let's click. Okay, let's quickly zoom in again. Because I may be clicking next to a building and then think it's a building if we zoomed out too far. So I don't want to be too far out. You can see the building colors. The building images looks very similar to bare soil. So that's a problem. Okay, so let's click that one there. I think that's a building there. Let's quickly put a satellite image there and see if I can take this out. Yeah, no, that's not a building there. There's buildings there. Okay, let's put it back in. So we must go there. That's a building there. Okay, let's click on that. That's a building there. You can see that's the spectral reflectance of that particular building. Let's go to the open field. Let's click that. And that will give you a respective reflectance value of that field. Now, if we just go 5 meters to the one side, it's all green, eh? It's all one particular land, so it shouldn't be that different. So let's quickly have a look and see how the spectral reflectance differ. So if I click there, let's have a look. See, have a mental image of that. Just go a bit to the right, and go there, and you see it looks very similar. There might be differences in the values itself, but it looks very similar. Okay, so that's how we can identify a specific feature of a specific thing, item, place, based on its spectral reflectance. If we know what the spectral signature is, we know what the spectral signature of a specific object is. Okay, then by using the spectral signature or deriving the spectral signal, we can say it's a X or it's a Y. Okay, but spectral signatures are marginal many times. There's marginal differences between spectral signature of different objects. And specifically, what we're going to focus on coming up is trying to identify urban by excluding bare soils. And that's a little bit more tricky. But, you know, between water and green stuff and vegetation and mountains, you know, that's fairly straightforward. But as I said, there's the margins. Okay, so now we've got an understanding of how spectral signatures work and what is the spectral signatures and why it looks like it does. let's go and play around with it a little bit more. Okay, remember we're not doing um, um, comparing work or anything, we're just focusing on this particular image and trying to get understanding of this image per se. So remember, we can play around with the image by going into the visualization parameters options, a window of this. So for that, you click on this little nut sign and this thing will come up. Now we can look at the individual bands. That's band 1. So let's have a look and see what band 1 looks like. Remember, band 1 is aerosols. Okay? And then we can go have a look at band 2. Remember, band 2 is blue. Okay, let's make sure. Band 2 is blue. Okay, so I'll put it there. So let's go to a palette scheme. And we're just basically going to do blue. And I'm just going down the blue rabbit hole. Blue rabbit hole. And let's go down there. One more. One more. And we're just going to say apply. Okay, so let's. Yeah, I've done it. So I've done it very, very, very fast now. So let's do that one there, and then let's do this one. Two different ones. See what happens now. Doesn't really show too much. Okay, so that's not going to work, but I think you get the ideas that we can create a color scheme here to present the blue ones. Okay, so we're not going to do anything. Let's have a look. We're just going to say apply. There it is. Okay, so that's band 2. That's band 3. Remember, band 3 is green. We're going to present it. So we can go to each and every band. Let's look at band 8A, which is, what is band 8A? It is red edge 4, and that's the wavelength. So that is light coming through that wavelength. Okay, so that's how that looks. You can see quite different. It's much more light, and it's much more focused on water. You can see the water, and that's that red, I think. So all these points here, this dark, this highlighted areas are water. So that's quite interested in showing water. You can see all these locations here. It's probably little farm dams and things like that. So that's all indicative of water. So A by itself is actually quite interesting for water. Let's have a look at 9. What is band 9 showing us? Also quite interesting for water. What is band 9 again? It must be something very similar. Yeah, band 9 is water vapor. Okay, so that's why it is quite sensitive on water. Let's go and have a look at 11. What does 11 mean? 11 is shortwave infrared. So let's have a look at that. Also strong on water, but also these green areas here, you can see there. It indicates those green areas, the circles form. Well, it's very good on identifying this text, the texture, whether it's round, circle, the boundaries of things. Segmentation. So it's very, very good in segmenting it into its different features. Okay, so that's very interesting. And then 12, let's have a look at 12. What is 12? 12 is also shortwave infrared in the second one. And these are all 20 meters and 10 meters. Okay, so let's have a look. And there we go. For 12. So that's having a look at all the individual bands. Okay, there's more of them, but that's the only ones that we're interested in. Okay. Then obviously we can look at them as the 3 bands together. So 4, 3, 2 is what we call the true color. That's the one that you and I would visually see. That's how we observe things. Okay. The aerosol, we're not going to use the aerosol. So what we can do is we can inverse these two. So we're going to start at 4, keep 3 and 4. See what that looks like. That's that specific color, which is like a dark purplish bluish color. Let's say we're going to do, let's say 3, 4, and 5. Let's have a look what that band combination looks like. That's something like that. let's use 6, 5, and 4. Let's see what that band combination looks like. That's a false color one, more or less a false color one. Then we're going to look at, let's say, 7, 3, and 4. Let's see what that looks. And there's all these combinations you can play with. So that's like a pinkish color. That's not very good. So let's change that to 4. Let's change that to 3 and see what that looks like. That looks like also like a false color. You can play around with it. Let's say 5 and 3. Let's see what that looks like. That looks like that. So play around with the band combinations. Each combination gives you a different look and feel of the image. It highlights certain ones and basically hides other ones. It highlights certain features and it hides other features based on these different combinations because they give you different, because you highlight different spectral signatures, etc. So that's how you present these spectral signatures. So an item that is very strong on reflecting, let's say in this case band 7 will feature prominent, where objects that's very prominent in, let's say, band 2 is not going to feature here much because we're not looking at band 2. So that's where these band combinations come in. And obviously, let's go back to our 432, our true color 432, and we press apply. Then we can get back to our true color, and then we can stretch. You see, now at the moment we're working with a range of 0 and 1000 because that's what we specified. Our minimum value, minimum value is 0 and the maximum value is 1000. So we, the moment working with that, but we can adjust these values, we can stretch them, we can move them around, or we can change them, and we can use, you can either type in the values there. So for example, we're going to go, let's say 100 and 300. Okay, so that's now the minimum value and the maximum value. Let's say we say apply, and let's see what that picture looks like. That looks like that. That looks like that. So we don't want to go and type in this time that change these values. In fact, that doesn't look too bad. Remember, what I'm interested is in urban areas. I want to see what the urban structures look like. So let's quickly have a look and see. There's an urban area here. So you can see that the sand and the urban areas looks very similar. So let's have a look. I want to see what the so let's have a look there. There's a facility there. So it is big in reflecting 11. So I need to 11, 12, and 8. Okay, so let's go. The top one is 11, 12, 12, and what was this? 8. That seems to be the bands that it reflects, that it has the biggest reflection. So let's quickly say apply. And I'm going to go back to my initial one of 0 and 1000. Say apply. And you see it creates this almost pinkish background. So if I go out, no, it doesn't really indicate it too clearly. So it gives it a much more greenish. Was that? Let's quickly swap it around. Let's go 8, 12, and 11. Let's have a look how that looks. Okay, so that gives you a greenish. So that could be interesting by itself. Yeah, that seems to highlight urban areas quite well, if you ask me. And it contrasts it against its soil. So that's urban areas there. Let's have a look at another place and see. But anyway, that's something we're going to still do, is to play around with this idea of identifying urban areas. So let's have a look and see what it looks like then. So it gives this greenish color. Let's go and make it change this one to 11 and make that one 12. What does that look like? This is this grayish thing. Other is green. So it converts non-urban areas more to green and stuff. And we can play around with. Let's say we want to stick with this. Let's say we're going to stretch it one. You see, all the stretching does, it changes these range values. Okay, just exactly that we did there. But let's have a look and see how that looks. Interesting, very interesting. Let's stretch it again by 2. So that's again stretching there. Let's have a look and see how that looks. That looks similar to the original one. Nothing too much there. Let's look at band stretching it 3 alpha. Now, that's a little bit boring, but it does indicate urban areas, I think, quite nicely. 90%, so that gives you 90% of both sides. See how that looks. We've gone for this one that's similar to what we've done already. States 98. Let's have a look and see there. How that looks, that's interesting. And then states 100%, which is close to, yeah, that's okay. So I think if we stretch it that amount, that still gives me, I think, a better contrast. We go out of here, let's have a look and see how that looks. Yeah, you can see the red, which is the sand. Let's go zoom in and see that is very, very red. That's very red. So this is this almost grassy, sandy area. Gives you high red values. You can see that. And then these greenish sandy area gives you quite high green. And then, yeah, so that's quite interesting. So this red area is very grassy, sandy patches. There's lots of them. And then obviously the green area. Dark green is natural vegetation. What is this red? This red is quite interesting. Oh, that is, this red is specific agricultural things. There's also red there. What is that red? It's forest area, trees. It's also like a very big red color. There's water. So this is quite an interesting look for this image. You can see the yellow is I think it's agriculture. Green areas, natural vegetation. White areas are sort of sandy area, and then you have your urban areas here, which is this sort of bluish color. Unfortunately, you can see this, yeah, it's more a grey blue, where a light blue is more sandy patches. You can see there's more sandy. White and light blue is more sandy patches. These are more dark, greyish blue, almost like a purple effect. And then this, yeah. So that's quite interesting. Okay, so one can play around with the color scheme and the bands to generate images where certain features stand out more than other features. And that, I think, is the whole idea, is if you want to identify certain objects or certain features, then you can play around with those bands and the range, the minimum maxi range, to either diminish certain features or highlight certain features. And that, I think, is quite interesting. And then obviously you can compare it images over time to see whether what certain features have decreased or certain features have increased or changes. That's still what we're going to do. Anyway, this is a sort of a quick workout on images and working with Sentinel images in Earth Engine. This is sort of a recap, and we're going to continue with this. So thanks for staying tuned. Much appreciated. Please remember to like and subscribe. I need the support, please. Our journey is still far. I need all the fuel I can get to get us to the end goal of our journey. We basically just started the journey. So please, 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 I'd much appreciate your company. I look forward to your comments and suggestions, and I'll see you on the other side.